Hey everyone, and welcome back to another explainer. Today, we're diving into a genuinely fascinating moment in the history of science. We're going to take a look at one of the most famous, and honestly, most delightfully named theories in physics. We're talking about J.J. Thomson and his absolutely groundbreaking attempt to map out the fundamental building blocks of our reality. So, right off the bat, you might be wondering, can a piece of cake actually explain the universe? It sounds completely absurd, I know. But back when scientists were first trying to unlock the secrets of what makes up everything around us, they really needed a way to visualize the invisible. They needed a model. And the one J.J. Thomson came up with had a decidedly whimsical, dessert-inspired flavor to it.
Okay, section 1. Let's dive right into this and meet the Plum Pudding Model.
This right here is where our journey into the microscopic world really begins. Let's start with the formal scientific baseline. Thomson proposed that an atom is essentially this positively charged sphere. And crucially, it's got these negatively charged electrons just sort of embedded directly inside of it. Think of it like a solid ball of positive energy that's holding onto these tiny little pockets of negative energy.
Moving on to section 2, inside the atomic cake.
To really translate that rigid textbook definition into something we can easily picture in our heads, I want you to stop thinking about an atom as a complex mechanical object with little gears and orbits. Instead, just imagine cake batter, or pudding. In Thomson's mind, this batter represents the positive charge. Notice the key idea here, though. That positive charge isn't just sitting in one spot. It's spread out completely uniformly, actually creating the shape and the structure of the atom itself. Okay, so if the batter is the uniform positive charge, what about the negative charge? Well, Thomson envisioned small raisins scattered inside that batter. And you guessed it, those raisins represent the negatively charged electrons. They aren't flying around freely. They are literally stuck right there inside the positive sphere. This visual, a pudding packed with raisins, is exactly why it earned its legendary name.
So the crucial point is the mathematical balance happening inside this cosmic dessert. The total positive charge of the batter is exactly equal to the total negative charge of all those little raisin electrons combined. Thomson realized that for matter to actually exist the way we experience it, these opposing forces absolutely had to perfectly cancel each other out.
And that exact mathematical balance leads us directly to this major conclusion. Because the positive and negative charges are entirely equal, the atom itself is electrically neutral. It doesn't have some massive, shocking charge in its natural state. The pudding and the raisins are just hanging out in a state of perfect harmony. And this brilliantly illustrates just how revolutionary Thomson's proposal really was at the time. I mean, before this, the atom was basically thought to be just a solid, unbreakable block. But this was the very first model to actually include electrons actively existing inside the atom. It suggested that atoms were divisible, that they were made of even smaller moving parts working together. Thomson literally broke the unbreakable block. But as with all great science, Section 3, why the model failed. Look, in science, even the most brilliant models are meant to be pushed to their absolute limits. Thomson proposed this uniform sphere with fixed electrons, but that static model just couldn't explain the dynamic reality of physics. It completely fell apart when trying to account for the results of the famous gold foil experiment, which, by the way, definitively proved atoms aren't just solid pudding, and it entirely missed the presence of a central nucleus. Which brings us to Section 4, the model's enduring legacy. So you might be asking, if the model was ultimately proven wrong, why do we still even study it? Well, let's move to and see how this builds the foundation of what we know today. A failed model is honestly just a necessary step on the staircase to the truth. Even though the Plum Pudding model was replaced, it introduced the whole concept of internal atomic structure to the world. By kicking that door wide open, his model directly led to the far more accurate atomic models we use today, the ones featuring a central nucleus and orbiting electrons. If there is just one single key takeaway to remember from our time together today, it's this simple, elegant summary right here. Thomson's model described the atom as a positively charged sphere with electrons embedded inside it like raisins in pudding. It perfectly captures this brilliant marriage of high-level physics and a totally relatable, accessible visual. Which leaves us with this final thought to chew on. Thomson's model was wrong, for sure, but it changed science forever by giving the next generation of scientists something tangible to test, challenge, and improve upon. So it kind of makes you wonder, right? What wrong ideas are we relying on today to build tomorrow's truth? Thank you so much for exploring this incredible slice of scientific history with me.
Keep asking questions, keep visualizing the complex, and I'll catch you in the next explainer.